So in this video, we're going to be talking about the first section of our Unit 3 this year, which is starting a unit on solving equations. So today we'll be doing the math thinking and class practice. Then tomorrow on Wednesday, we'll be doing our proficiency practice, our CFU, and then the final practice on Delta Math. So to start off with, let's go ahead and just take a look at plotting solutions on a number line. So this one says mark each number on the line with a point to reflect the solution given by x. For fractions, estimate the point between two integers. So if I'm doing this here, if I want to plot the solution x equals 2, I'm just going to put a solid dot on 2. If I want -4, I'm going to put a solid dot on -4. X equals 1/2. That's halfway between 0 and 1, so somewhere in there. X equals -3. X equals -5. And for 4.5, we're halfway between 4 and 5 right there. So we're going to be plotting our solutions for some of these equations as we go through this unit, mostly just to practice this idea for the next unit, which is inequalities, where we'll be plotting pretty much every single one of them. Up next, we're going to talk about computing vertically using addition and subtraction. Up until now, everything we've done has been horizontally. So something like 6 minus 4. We're going to do it vertically today because when we're solving equations, this is the way it's going to be laid out. So using your number line here, if I start at 0, I go +6, and then -4. I'm going to end up at 2. I'll let you keep going there. You can pause the video and finish those out if you want. Okay, so moving on here. If I have -3 and then +2, I'm going to end up -1. 1 minus 4 gives me -3. This one seems to throw people off the most. -5 minus 2 is -7. 4 minus 5 is -1. And -2 plus 6 is a +4. From yesterday, I want you to remember when we add or subtract numbers that are one positive, one negative, we call those zero pairs, or additive inverses. I can write better than that, can't I? Apparently my screen isn't working here. But anytime I take a number like 3 plus -3 or 3 minus 3, I'm going to get 0. Those are zero pairs. They're additive inverses because they add up to 0. -1 plus 1 is 0. 4 minus 4 is 0. -5 plus 5 is 0. Those are additive inverses. Addition and subtraction are inverse operations because it helps us to make those zero pairs. They undo each other. When we're trying to solve equations and we have a -1 in the equation that we want to get rid of, we're going to use the inverse operation of +1 to get rid of those. I'm going to go ahead and highlight that. Inverse operations. You're going to hear inverse operations a lot this year in algebra. Now, when we go to multiplying and dividing, if I have something like 2 divided by 2, I get 1. 3 divided by 3 is 1. If I remember back from yesterday again, when we were doing the getting ready for Unit 3, if I take 2 times 1/2, 2 over 1 times 1/2, those are reciprocal fractions. So I get 1. 3 over 1 times 1/3 is 1. And so again, multiplication and division are inverse operations. If I have a times 2, I'm going to divide by 2 and I get 1. If I have a 1/2, I'm going to multiply by 2 to get 1. What we're looking for here is it helps to make a coefficient of 1. Anytime we use a multiplicative inverse, we multiply or divide by the number, we're going to end up with a 1 as a coefficient. And if you remember, we're not going to write that 1x. That's just going to be x by itself. You can think of these as undoing each other. We just want to be really careful that when we talk about undoing with addition or subtraction, we're getting 0. When we're undoing with multiplication, we're getting a coefficient of 1. So slightly different things there when we're solving equations. Next up here, you can pause the video if you need to, but when we talk about algebra, we're talking about mathematics that uses variables to represent numbers in equations and formulas. And I'm just going to add in here, when we're representing those numbers with variables, it might be that we don't know those numbers, or it might be that they're changing. So either an unknown number or a changing number is what we're using for variables in algebra. If we know the number and it never changes, we'll just use a constant in that case. And our goal when we're solving algebraic equations with one variable, which is what we're going to be doing most of the time this year, is always to end up with x is equal to a number. So at the end of our equation, we want to end up with something like x equals 5 or x equals 1/2. And to do that, we're going to use inverse operations to isolate the variable. Our main focus this unit is not just getting the solution. It is to use those inverse operations and actually work through the process of solving an algebraic equation. So let's go ahead and try that out. If I look at this first equation, one thing I want to just address real quick here is I would be willing to bet that you know the solution to that without doing anything else. Most people can look at that and go, oh, I know that 5 plus 2 is 7. The answer is 5. That's not our goal right now. Right now, we want to focus on showing our inverse operations because we are learning how to do a process that is going to go beyond one-step equations. Eventually, I want you to be able to solve an equation. Just as an example, I would like to be able to solve an equation like this at some point in time. And there's no way you know what that answer is. It would help if I put an X in there, wouldn't it? There's no way you would know what that answer is right off the top of your head, just like you would in the first one. But by doing our inverse operations like we're going to show you this unit, you're eventually going to get there. So when you're solving these equations, what I want you to do is look at what is being done to the X, look at what is being done to the variable, and our goal is to do the inverse of that. I like to draw a line down the equal sign. It helps me keep track of the left and the right side. Every once in a while, people like to switch the X's around on you. So if I notice that there's my X, I look at what's happening. I'm seeing plus 2. I'm taking X and I'm adding 2 to it. I want to do the inverse operation. So I'm going to subtract 2. If I subtract 2 on the left-hand side, I have to subtract 2 on the right-hand side. We think of these equations like balancing. They have to balance. If we do something to one side, we have to do the same exact thing to the other side or it's no longer balanced. And then I'm going to actually do that. On this left-hand side, 2 minus 2, like we know, is 0. I'm not going to write x plus 0. I don't need to do that. I'm just going to write x. On the right-hand side, 7 minus 2 is 5, and so I have the solution x equals 5. Use this opportunity for your first unit or first lesson in the unit. You should know what that answer is. If you don't get that answer, then that would be a problem. This next one, I'm going to do the same thing. I see that I'm taking x plus 1. So I know I need to do the inverse operation, which is minus 1. I'm going to do minus 1 on both sides. Plus 1 minus 1 is 0, but I'm not going to write x plus 0. I'm just going to write x. 4 minus 1 is 3. What we're going to have you do this year, or at least right now, is we're going to have you rewrite that equation so that the x is on the left-hand side. So it always says x equals a number. These are the exact same thing mathematically. Right? 3 equals x, x equals 3, same exact thing. We're going to get used to putting it in this orientation because coming up later on with other things that we're going to learn, inequalities is our next unit. It is really nice to have it in this form with the x on the left-hand side. So we're going to rearrange it to put the x on the left-hand side. Next up, we've got something like this. I'm going to draw my line. I see an x minus 2. So I'm thinking to myself, what is the inverse operation of minus 2? And that is plus 2. So I'm going to go plus 2 on both sides. Make sure that you're writing the plus on there. Don't just write 2. And I'm going to add them up. Negative 2 plus 2 is 0. But I'm not going to write x plus 0. I'm just going to write x. Negative 4 plus 2 is negative 2. And so my solution, x equals negative 2. And my last one is where we start to get a little bit tricky here. We've got negative 3 plus x equals negative 2. So we are trying to get rid of this -3. When I'm looking at that, I'm thinking, what is the inverse operation to a -3? And that is a +3. Focus on just the thing you're trying to get rid of. That is a -3, so I'm going to add 3. I'm going to add 3 to the other side. -3 plus 3 is 0, but I'm not going to write 0 plus x. And I'm not even going to write plus x. I'm just going to write x. That plus is always implied if it's not written there. On the other side, -2 plus 3 is 1, so I've got x equals 1. So on these, make sure that you are writing those steps out. The goal here is not to get the answer as fast as you can. The goal is to practice with writing our inverse operations, showing our steps so that as these equations get harder and more complicated, we are able to still solve them. You're going to very quickly, by the end of next week, have equations where you cannot just look at them and see the answer.
Lunch students are now dismissed for lunch.
Awesome. So our next section here is all about adding and multiplying and dividing to find solutions. So when I look at an equation like number 5, I have 2x equals 6. We need to remind ourselves, what does 2x mean? And even though we don't put any symbol between the 2 and the x, that means times. So if I see 2 times x, the opposite of that is divide. So I'm going to divide by 2. I have to do it on both sides to keep it balanced. On the left-hand side, 2 divided by 2 is 1x. But I just need you to remember, we don't really write the 1 there. You can leave yourself a note if you need to. 2 divided by 2 gives you 1x, but we don't write the 1. On the other side, 6 divided by 2 is 3. So we have our solution, x equals 3. For number 6, we've got the same thing with negatives. So this is, again, another place that we're being careful here. Ask yourself the question, what is happening to the x? And I am multiplying that x by -2. This is a times, -2 times x. So the inverse operation is not +2, it is divided by -2. So I'm going to divide by -2 on both sides. -2 divided by -2 is 1. I'm not going to write the 1, I'm just going to write x. And -10 divided by -2 is a +5, because a negative divided by a negative is a positive. So I'm just going to go ahead and rewrite that equation, x equals 5, so that the x is on the left, and we have x equals a number. Then we get our fractions, and so this is why we wanted to talk about fractions and reciprocals yesterday. What we talked about was that anytime you have a fraction times its reciprocal, you always get 1. And so when we need to undo a fraction, a fractional coefficient, we are always going to multiply by the reciprocal. I'm just going to write that down here. I have no idea if that's spelled right. We're going to pretend it is. So if I need to get rid of this 1/2 in front of the 1/2 times x, I'm going to multiply by the reciprocal, 2 over 1. I need to do the same thing on the other side. On the left, 2 over 1 times 1 over 2 is 1, but I'm not going to write 1x, I'm just going to write x. On the right-hand side, remember this 4 is really 4 over 1. And when I multiply fractions, I just multiply straight across. So 4 times 2 is 8. 1 times 1 is 1. And 8 over 1 is just 8. So my solution here, if I write it out, is x equals 8. On the next one, I've got 1/3 x, so I'm going to multiply by my reciprocal of 3 over 1. On the left-hand side, 3 over 1 times 1/3 is 1x. I'm not going to write the 1, just the x. On the right-hand side, -4 over 1 times 3 over 1. Multiplying the tops gives me -12. Multiplying by the bottoms gives me 1. And so my solution here is x equals -12, because -12 divided by 1 is -12. I do want to just show you one example here that is not in your note packet. If I had something like 2/3 x equals 6, about how we would solve that. Same exact idea applies. If I have a fraction times x, all I need to do is multiply by the reciprocal. So if I have the reciprocal of 2/3, I'm going to multiply by 3/2 on both sides. 3/2 times 2/3 is 1. I'm not going to write 1x. I'm just going to write x. Over here, I'll put the 6 over 1 and multiply the tops. 6 times 3 is 18. 1 times 2 is 2. And if I simplify 18 divided by 2, I get 9. So there might be a first example of one where you might not have been able to look at that and see what the answer was. But by using our inverse operations, we're able to figure out what the solution is. So keep the idea that today, especially these first couple of lessons, the goal is not to get the solution. The goal is to show your inverse operations. Okay, last two here are some examples of some word problems for these things. Again, I want you to look at the directions here. It says write an equation and solve. It does not say how old is Jackson's mother. If you just tell me she's 25, that's not answering the question. So Jackson is 5 years old. His mother's age is unknown. The sum of their ages is 30. Let M equal the age of Jackson's mother. So one of the first things you might need to look at is, what does the word sum mean? Remember, that means adding. So if we take Jackson's age plus his mother's age, it is or equals 30. So Jackson is 5. His mother, we said, is M. And we know that equals 30. That's our equation. So we're going to go ahead and solve that equation. We have a positive 5 there, so we're going to subtract 5. We'll subtract 5 from the other side to keep it balanced. Positive 5 minus 5 makes 0. I'm not going to write 0 plus m. I'm just going to write m. And on this side, we, of course, get 25. All right, this is the work I need to see, not just an answer. And the very last one here, 2 times an unknown number is 10. Let n equal the unknown number. Write an algebra equation and solve. So 2 times an unknown number. When we write 2 times an unknown number, one thing I want you to remember here is we don't usually put that dot in there. We usually just write 2n. So 2 times an unknown number is or equals 10. From there, I know that this is multiplying 2 times n. The inverse operation is dividing by 2. 2 divided by 2 is 1, so I'm not going to write 1n, I'm just going to write n. And 10 divided by 2 is 5. So my solution, n equals 5. So on your proficiency practice, you've got, I think it's 5 questions of solving equations using addition or subtraction, 5 equations using multiplication and division, a couple of equations with fractions, and a couple of word problems. And then you are on to the CFU and the Delta Math after that.